Welcome to the severe weather analysis for Hobart, Thursday, November 27, 2025. This morning's sounding was taken at 10 a.m. local time. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at this morning's sounding, we are seeing a very stable atmospheric profile with minimal convective energy available. The mixed layer CAPE is essentially zero at just 1 joule per kilogram, and even the surface base CAPE is only 193 joules per kilogram. That's extremely low energy for any storm development. The dewpoint depression at the surface is 7.6 degrees Celsius, indicating relatively dry conditions near the ground. The lifted condensed level sits at 941 meters above ground, which is favorable for convection if we had sufficient energy. What's interesting is the complete absence of a capping inversion. There's no lid holding anything down because there's simply not enough energy to require one. The atmosphere is essentially sub-convective this morning. Let's examine what happens when we heat the surface parcel to the forecast maximum of 13 degrees Celsius. The enhanced plot shows the multi-parcel comparison, and we can see the pink shaded area showing CAPE with the blue shaded area showing CIN. After heating, the most unstable CAPE increases to 357 joules per kilogram, still very weak by Australian standards. The heated parcel path, shown in orange, rises through the unchanged morning environment. The lifting condensation level drops slightly to around 855 hectopascals. Even with this afternoon heating, we remain in a subconvective regime. The supercell composite parameter rises to 1.8, and the significant tornado parameter increases to 0.80, but these values are conditional. They only matter if storms can actually initiate, which is highly unlikely given the insufficient CAPE. Looking ahead to tomorrow morning, the machine learning forecast shows CAPE remaining at 0 joules per kilogram with surface-based CAPE also at 0. The 0 to 6 kilometer shear increases significantly to 27.4 meters per second, and the lifting condensation level sits at 1,344 meters above ground. The storm mode remains subconvective due to insufficient CAPE, though if any storms did manage to initiate, the strong shear would support organized severe weather. Tomorrow afternoon's machine learning forecast continues the subconvective pattern. CAPE and surface-based CAPE both remain at 0 joules per kilogram. The 0 to 6 kilometer shear strengthens further to 29.4 meters per second. Quite impressive shear, but without fuel, there's nothing to organize. The lifting condensation level improves to 875 meters above ground. All tornado, hail, and wind threats remain conditional, possible only if storms somehow manage to initiate against the unfavorable thermodynamics. The hodograph reveals some fascinating wind structure despite the lack of convective energy. We are seeing very strong deep layer shear of 57.7 meters per second from the surface to 6 kilometers. The wind profile shows substantial directional shear, with winds veering from light southeasterly at the surface through westerly aloft. The color-coded height markers show the wind evolution through the boundary layer, greens and yellows in the mid-levels indicating heights around 5 to 7 kilometers. The right mover bunker's storm motion vector points east-northeast, so if supercells did develop, they would track toward the east-northeast. The storm relative helicity values are moderate at 166 meters squared per second in the 0 to 1 kilometer layer and 246 in the 0 to 3 kilometer layer. This is a classic case of excellent shear going to waste due to lack of instability. The atmospheric refractivity profile, or N profile, shows the vertical structure of atmospheric stability. The blue line represents the Brunt-Väisälä frequency, which measures atmospheric stratification. We are seeing a smooth, stable profile from the surface up through 10,000 meters, with gradual changes in refractivity. The orange shaded band near 1,200 meters indicates an elevated duct layer, which can trap radio waves and create interesting propagation conditions. This stable profile confirms what we've seen throughout the analysis: a very stable, subconvective atmosphere with no significant layers of instability or elevated mixed layers that could support convective development. In summary, Hobart faces a subconvective day with insufficient energy for storm development despite impressive wind shear. Always consult the Bureau of Meteorology for official warnings and forecasts. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.